In this lesson, we're going to be looking at domain and range. This is going to take place over 2 different lessons that we're going to be learning. The first part is going to be just the simpler domain and range, and then we will add in finding the union between broken graphs. We first want to go through a few definitions so that we can get some understanding before getting started. Number 1, a function is a special relationship between variables where each input has a single output. On a graph, we can use something called the vertical line test. And basically what that is it's a test to tell whether it is a function or not. What you're going to do is simply draw a vertical line through the graph. You can draw it anywhere in that particular coordinate plane. We want it to only hit the graph one time. If it hits the graph more than one time, it is not a function. So this is a function because it passes the vertical line test, where this would not be a function because when I draw that vertical line, it's going to hit that graph in 2 separate places. What that's saying is it's going to hit where that particular x value of -1 has 2 different y values, one at approximately -3 and one at approximately +3. So there's a repeat x value for that graph. So this would be not a function. This lesson is going through the domain of functions. What we need to know is specifically and most important, the domain is the set of all x values of the graph. We are going to be looking at the graph from the left to the right. The range of the graph is all of the y values of the graph, and we are going to be looking at that graph from the bottom to the top. The reason we do this from the left to the right is because it goes in the order from smallest to largest. And the same thing from the bottom to the top. It's going from the smallest number to the largest number. So when you write your numbers, okay, you should always see the smaller number come first and then the larger number. We're going to be writing these in something called interval notation. We have 2 different types of things we're going to use, either a set of parentheses or a set of brackets. I'll walk you through when you're going to use both of those. A set of parentheses is when you are going to positive or negative infinity, meaning the graph is going all the way to the left or all the way to the right, or possibly it's going all the way down and all the way up. Another time when you would use a set of parentheses is if there is an open circle. So you see a graph and it starts with an open circle. You're going to use a bracket when you see a closed dot or a closed circle. Okay, or if the graph lies on the line. I'll talk about what that looks like here in a moment. So when we look at these, again, we're going to be writing them in interval notation. Interval notation is going to go from the smallest to the largest. So smallest to the largest. Whether you're using parentheses or brackets, it's always going in that order. You also can have a combination of brackets and parentheses, could be bracket, parenthesis, and then a bracket. So there's a lot of different ways that these look as you're going through them. And we're going to look at several examples as we're going through these particular problems. We're going to start with this one here. So what I would recommend is that we just take a second and we grab maybe like a highlighter, or it doesn't have to be a highlighter, it could be a colored pencil or a marker or a pen of some kind, where you can mark up these graphs, something other than a pencil, so that you can see the line when you're drawing it down. I'm going to use a color, red. So remember, the domain is going to go from the left to the right. So what we're going to do is we're going to take our marker or our colored pen and we're going to draw a line that's on the farthest left and the farthest right of that graph. What this does is this helps you tell where the left side and the right side of that picture are. This left side is at -3 and the right side is at +3. Notice those are smallest to largest. Now we have to decide whether we're using a bracket or a parenthesis. Do you see how this line falls right on that X value? And this falls right on that. And when I mean falls on that X value, I mean this line that you've drawn in. It doesn't have a dot per se, but it's right on that X value line. That means we're going to use a bracket there. I'll use a different color and we're going to look at the range. Remember, with the range, we're going from the bottom to the top. Okay, we were just looking at the X values. Now we're going to be looking at the Y values. When I go all the way across, I have the bottom of the graph to the top of the graph. The lowest at the bottom is -3 again, and the top is +3. Again, it doesn't have a solid dot, but it is right on that line of -3. And the same with this, it's right on the +3. You'll know when you're going to use a set of parentheses. Again, you're going to see an arrow. If you hit an arrow, you know it's going to infinity. Therefore, you see a set of parentheses. If there's an open circle, you would use a set of parentheses. If there's not either one of those, then it's going to be a bracket. Now, we'll ask ourselves, is this a function? No, this is not a function. If I draw that line there, that's a vertical line passing through the graph. It's going to hit that graph more than one time. Let's take a look at this one. Why don't you pause really quickly and see if you can write the domain and the range according to the X values and the Y values for that graph. Okay, hopefully you have X and X. Hopefully you have the domain being -3 going all the way to 6, lying both on those lines, -3 to 6. Here again, this X value is, we're always looking at this axis. This line is on X equals -3. This line is on X equals 6. I'm going to do the same thing. Hopefully you have the range done. We'll go this way from the bottom to the top. Now remember, with the range, we're looking for the Y values. So the y values cross the y-axis. The lowest y value would be -1. The highest y value would be 8. Both of those are right on the line. And you can even see here, there's a closed dot there. So we know that it's going to be a bracket. Is it a function? Hopefully you wrote no. All right, so let's get into some different ones. Here we see this graph. It right away, you can see that it starts with a open circle. So when I look from the left to the right, the left to the right is going from -2 all the way to +2. Here's where we start to see some open circles. So on this line, x equals -2, it's got an open circle there. This is an open circle. Therefore, we know that we need to use a set of parentheses. This x equals 2, the farthest to the right, it has where it's falling right on that line. So that's going to be a bracket. When we look from the bottom to the top, the lowest to the highest y, the lowest y is -2. The highest y is +2. Notice the lowest y has an open circle. The highest y has an open circle. You can also think of it as, if I'm going to scroll along this graph, if I go up to the graph, the first thing that I touch is an open circle. So I know that that's going to have to be a set of parentheses. Is it a function? Again, no. I can't draw that vertical line without hitting the graph twice. Now I could draw the vertical line right here, but you have to think about it has to be anywhere on that particular picture. All right, let's go down and let's change up a little bit. So now we're going to be looking at lines where you have some arrows. Again, we're going to go from the left to the right, looking at the x's, and then from the bottom to the top, looking at the y's. You can keep using your highlighter if you'd like. If you want to change back to your pen, you can. From the left, I'm at -2, all the way to the right. Now I know this graph stops, but if you think about it, that graph just keeps going. It would just keep going higher and higher and higher. So when you think about where it's going on the right, it's going to positive infinity. I know it's going up. Yes, you're right. It's also going up. But as it's going up, it's also going to the right. When you are thinking about drawing your line over here, you could draw your line right here, but it's going to touch an arrow. So because it has an arrow on the right, that means it's going to positive infinity. So this graph is going from -2 to infinity. Look at the range. We're going to go from the lowest value, again, y equals -2. And when we look at the top of the graph, when we're coming into the top, the highest that we get to, it's also touching an arrow. So that is going to go to infinity. So whenever it gets to an arrow, it's going to infinity. Let's look at this one and we're going to do the same thing. We're going to go on the left and the right first, the left and the right. You'll notice on the left side, we have an arrow. On the right side, we have an arrow. Now don't be fooled. Again, it looks like it's going down, but as that graph goes down, it also goes out and to the right. And same as this, it's going out and down to the left. Since it's hitting an arrow on the left side, it's going to negative infinity. And since it's hitting an arrow on the right, it's going to positive infinity. And we always use a set of parentheses on infinity. The range, from the bottom of the graph, we hit 2 arrows. So we hit an arrow, therefore it's going to negative infinity. The top of the graph is going to the highest value of 0. You can see that it's actually on the line y equals 0. Therefore, we're going to go back and use a bracket. So parentheses on infinity, a bracket when it's on the line. Is this one a function? Yes, this one is a function. I think we missed that on this last one, so we'll look back at that. This one, yes, is also a function. So let's look at this one. Why don't you take a second and pause and see if you can write the domain and the range of this particular graph. All right, hopefully for this graph, on the left, you have an arrow. On the right, you have an arrow. That arrow signals that this is going to negative infinity and positive infinity. Again, this is going from the left to the right. So as this graph goes up, it's also going to gradually go to the left. And as this goes up, it's going to gradually go to the right. The range, hopefully you saw the bottom of this. This is a little hard to see. I'm just going to go ahead and put that at -6. The top touches an arrow, so it's kind of backwards from the last one. Hopefully you saw that. The top is touching an arrow, so it's going to positive infinity. This particular graph, when we look at this, if I go to the farthest of the left and the farthest of the right, I hit negative infinity to positive infinity. I hit an arrow and an arrow. Always parentheses with infinity. On the bottom of the graph and on the top of the graph, I hit an arrow and an arrow. Negative infinity to positive infinity. This graph also is a function. This one's very similar. When you look at this one, farthest on the left, hit an arrow. Farthest on the right, we hit an arrow. Farthest on the bottom, we hit an arrow. Farthest on the top, we hit an arrow. What I don't want you to get confused is this point right here. Yes, that point does dip down, but you're always looking for the smallest or the lowest value. And here you can see that this graph is just going to keep going lower and lower and lower and lower. So this is no longer the lowest point. That one's going to negative infinity. Always think about where the graph is going. So again, this is an example of where you're seeing negative infinity to positive infinity for both of those. Yes, this one is also a function. So backing up again, we've seen some here that are closed figures. These next couple are, again, a closed figure where you have 2 endpoints. That second row, you're seeing one end going to positive or negative infinity, and the last one, you're seeing all of them going to infinity.